Good morning, ladies and gentlemen. I'd like to thank, firstly, the Thunderbolts project and the EU organisers for inviting me again to address you this year. And I'd also like to correct a little thing that Ev just said. He called me Dr. Crothers. Well, actually, I'm not doctor, and so I'm just Steve Crothers. Okay. Today I'm going to speak to you about LIGO, which you know is the laser interferometer gravitational observatory and its claims for black holes and gravitational waves. I'd like to read to you from the LIGO team's Discovery Declaration, or the Discovery Paper. This is their declaration. The basic features of GW150914 point to it being produced by the coalescence of two black holes, that is, their orbital inspiral and merger, and subsequent final black hole ring down over 0.2 seconds. The signal increases in frequency and amplitude in about 8 cycles from 35 to 150 Hertz, where the amplitude reaches a maximum. The most plausible explanation for this evolution is the inspiral of two orbiting masses, M1 and M2, due to gravitational wave emission. Abbott et al. In this paper in Physical Review Letters. Now, the two things to note here, the two masses, that's the first thing, and the gravitational wave emission. These are things to dispute. Here's a table from their paper, LIGO's binary black holes. It's a binary system, you see. The two black holes that they say that they first started with was one of 36 solar masses and the other with 29 solar masses. And after they allegedly combined to form one black hole of a different type, they were 3 solar masses short. Those 3 solar masses were radiated away as gravitational wave energy, allegedly. I'd like to review some things that I've done in the past regarding incompatibility of universes. I've put a list here on the left-hand side of what constitutes fundamentally a black hole universe, and on the right-hand side, what constitutes a Big Bang universe. Now, recall that black holes are part of a Big Bang universe, allegedly. All of this gravitational waves, etc., it's not just black holes, it's inside some Big Bang universe. And there are, let's have a look at the left side. I'll begin with the right side, in fact, a Big Bang universe. Now, there are 3 types of Big Bang universe, and they are categorized by their K curvature. And so we see that the Big Bang universe has a K curvature, but no black hole universe has a K curvature. And yet, they are supposed to be in the same universe. Now, the 3 Big Bang universes depend on, as I said, K, and if K is equal to 1, it's finite. It has positive curvature and it has a finite spatial size. But a black hole universe is spatially infinite. One can only wonder how you can fit an infinite black hole universe inside a spatially finite Big Bang universe. Similarly, the other 2 universes of Big Bang are K-1 and K-0. They are spatially infinite. Well, the black hole universe is infinite, but it doesn't have a K curvature. The other thing about a Big Bang universe, all of the 3, is that they are allegedly 13.8 billion years old. But all black hole universes are eternal. They don't have any beginning or end in time. So how can you put a black hole universe inside a Big Bang universe when they don't even have the right age? All Big Bang universes are allegedly expanding, but no black hole universe is expanding at all. Black hole universes are allegedly asymptotically flat. Now, this means that as you get further away from the black hole, the so-called curvature of space-time gets less and less, and it's asymptotic. So as you continue to go without any bound, infinitely, it becomes flatter and flatter. But none of the Big Bang universes are asymptotically anything. And the black hole universe contains only one mass. That is the black hole itself. Recall that the LIGO team claimed that they have 2 black holes coalescing to form one black hole, emitting gravitational waves within a Big Bang universe. And the Big Bang universe allegedly contains many masses. So you see that they are fundamentally incompatible. Mathematically, physically, whatever they're described by, they are logically incompatible. Yet, the LIGO team claims to have found 2 of them, not just once, but 3 times now. So that's what, a total of 6 black holes in a Big Bang universe of which they don't really specify, but as we see, they are logically inconsistent. So certainly they didn't find any black holes in a Big Bang universe emitting gravitational waves. I'd like to go further over some properties of the Big Bang universe. The finite mass is concentrated at its singularity. And this singularity has zero volume and infinite density. It also has an event horizon. The black hole has an event horizon. When you pass the event horizon, there's a point of no return and it goes into the singularity. But there are forces in general relativity, but gravity is not one of them. And the reason is that in Einstein's theory, gravity is space-time curvature. It's not a force. Now, the infinite space-time curvature there's infinite space-time curvature at the singularity. Let's think about that. A finite mass is located in zero volume, has infinite density, and has infinite gravity. Do you think any such thing exists? Well, I certainly know that no such thing exists. As I've said also, they have an escape speed. The event horizon is the speed at the event horizon they have an escape speed that's the speed of light. The question is, what is the speed of light at the event horizon? Well, I'll cover that in another slide, and we'll see that this argument is also logically inconsistent. The asymptotically flat infinite space-time, not expanding universe, eternal, and a single mass, as I've already said. So we see that these are the alleged physical properties of a black hole universe. Here we have a diagrammatic representation of a black hole. I had to draw it in white, otherwise you wouldn't see it, because it's on a black background. And so I've put a blue arrow there. That's dark matter. And it's an event horizon. The singularity is right at the center, at the end of that little red radial line. And we see that they have a Schwarzschild radius. They call it R sub black of light. Now, the speed of light in vacuum is something like 300 million meters per second. Excuse me. And this is an eternal, infinite, asymptotically flat space-time. Now, here are now my diagrammatic form of multiple black holes. Again, they're all in white, and they're various sizes because they come in sizes, but sizes is not a type of black hole. They're just different sizes. Human beings are different sizes, but they're still all human beings. There are 4 different types of black holes, alleged. Now, we look at this little diagram, we see that there's eternal, infinite gravity at each one of them, right at their singularities. And they're all supposed to be inside a 13.8 billion year old Big Bang universe. That's not asymptotically anything. Consider any one of those black holes in that diagram. They all have the same characteristics, a singularity where we have zero volume, infinite density, and infinite gravity. And they're also supposed to be asymptotically flat space-times. Now, every one of those black holes encounters what outside of it? Another black hole which has infinite gravity. Well, that's infinite space-time curvature. That's a long way from being asymptotically flat. So you see, you can't have, even on the idea of a black hole, if we take that at face value, you can't have multiple black holes by the very definition of the black holes. Here is a technical issue regarding mathematical forms. It's called the principle of superposition. Now, general relativity is a nonlinear theory, and that means that the principle of superposition does not hold. So if you have, say, X as a black hole universe and Y as a Big Bang universe, then X plus Y is not a solution. It's not a universe in this theory. Neither is X plus Y or X plus X, Y plus Y, etc., any combinations thereof, because that's just superposing, and that violates the mathematical form of the theory. Nonetheless, what does Abbott and the LIGO team tell us? Here's what is in their discovery paper. It matches the waveform predicted by general relativity for the in-spiral merger of a pair of black holes and the ring down of the resulting single black hole. So how did they get these black holes in their Big Bang universe? They superposed. Everything's just superposed. But you can't superpose because you need to have a set of Einstein's field equations to describe any configuration that you want and then solve them for that configuration. You can't just superpose things upon the other because of this nonlinearity. So I want to now remind you about escape speed. In Newton's theory, the escape speed is given by this formula. V escape is the square root of 2gm over r, where r is the radius of the object, a spherical object. M is its mass, g is the universal constant for gravitation. Now, escape speed is a two-body relation. If I take a ball and I throw it into the air, that left the Earth, but it didn't escape because I didn't throw it fast enough. And if you throw or fire something fast enough, it will continue to go up and not come back. The minimum speed that you have to leave the Earth with is called the escape speed. And it's a two-body relation, because if you have one body in the universe, there's nothing to escape from anything. So it's a two-body relation, despite the fact that there is only one mass that's present in the actual expression for the escape speed. But to get that expression, you need to invoke Newton's theory of gravity, where there are two masses, which you see there is given by F is equal to gm, large m, small m, over r squared. So it's fundamentally a two-body relation, whereas a black hole is a one-body universe. So how can a black hole have an escape speed when it's in the universe on its own? It cannot. So let's go a little further with the escape speed issue. This comes from the Dictionary of Geophysics, Astrophysics and Astronomy. They're all experts, so they tell us. In general relativity for spherical black holes, Schwarzschild black holes, that's what they are, spherical, exactly the same expression RBH holds for the surface of a black hole. That's the expression I just gave you from Newton. Let's quickly go back to it. There's Newton's expression. That's a two-body relation. And they say it's the same expression. The surface of a black hole at RBH is a null surface consisting of those photon trajectories, null rays, which just do not escape to infinity. This surface is also called the black hole horizon. The required radius, RBH, follows from setting V escape equal to c. C is what? The speed of light, some 300 million meters per second. There's the equation that they use for the black hole radius. 2gm over c squared. Well, that's just a rearrangement of Newton's formula, Newton's expression, which is a two-body relation. Let's have a look at now how they confound two different escape speeds at the same place, at the same time, in the one equation. This top expression is called a metric, and it's actually a solution that's for a so-called Schwarzschild black hole. And light travels along a null line. So that means that ds squared on the left-hand side of this equation for light will be 0. So we put 0 in there on the left-hand side in the second line. And then we can look at it without any loss of generality by considering an equatorial plane. That means theta can be 90 degrees, and sine theta is 0. So the sine theta term drops out. And d theta, which is just a differential element of a constant, is also 0. So that right-hand side drops out completely, and we're left with this middle expression. Now, if we rearrange this middle expression, we get dr over dt. Well, that's just distance over time. Distance divided by the time taken is a speed. So we get speed, and this expression here is the dr dt. Then they say, at the event horizon, well, at the event horizon, what's the value of r? Well, we just saw that it's 2gm over c squared. So if we put 2gm over c squared in the value of r, we get 1 minus 1, that's 0. And they tell us here, we find that the velocity of light at the event horizon is 0. So the escape speed is the speed of light. To get c in the first place, they used Newton's formula, and it's 300 million meters per second. In this very equation now, they use the same escape speed. Then they tell us that the escape speed is 0. So in the one equation, we have two different escape speeds for at the same place, which is quite impossible. You can only really shake your head in amazement at how cosmologists do things. Here's the Schwarzschild radius of a black hole. 2gm over c squared, where c is allegedly the escape speed of 300 million meters per second. But we just saw that they told us it's 0. The other thing, of course, is that in this geometry, it's not Euclidean. Einstein's fancy non-Euclidean four-dimensional geometry. It's Riemannian or pseudo-Riemannian. And so this expression, or this quantity r that appears in these equations, is not a radius and it's not even a distance. And yet they adorn it with the properties of a radius when, strictly speaking, it's not a distance at all in this expression. Here we go again with the Schwarzschild radii. It's not a radius, remember? But they tell us here, this is from Wald, his book on general relativity. It's quite a well-known book. It's another fairy story from A to Z. A Schwarzschild black hole of mass equal to that of the Earth, it has a Schwarzschild radius of 1 centimetre. He says it's a radius. No, it isn't. A black hole of 1 solar mass has a Schwarzschild radius of only 3 kilometres. Well, no, it's not a radius. And that's where the escape speed is, which I just spoke of, having that schizophrenic property. Here we come again to the idea of forces, gravitational forces. In general relativity, as I said, gravity is not a force because it's space-time curvature. Now let's consider a spring. These are pretty unsophisticated looking springs because I drew them myself and I didn't have much software to do it with. Anyway, we take a spring horizontal. And let's assume that the left-hand side of this spring is fixed to a wall or something, so it can't move. And you want to stretch this spring or compress it. What do? You apply a force to it. Or you could pull it with your hand, or you could push it. And that's a force. Springs respond to forces. Now let's turn the spring vertical. So now it's stuck to the ceiling, say, and we put a weight on it. What pulls the spring down? It's weight. What is weight? Weight is a force. The spring responds due to a force pulling the spring. But there are no forces of gravity in general relativity. So this spring would have to be stretched or compressed by curved space-time. It doesn't make any sense at all. You can consider, for instance, if you're as old as me or older, you'll know that when you go to the grocery shop in those days, you used to have a spring balance, and he put a bag of spuds on there, and you say, well, you owe me $10 because it weighs this much. That's a weight. Did space-time curvature or a force stretch his spring? Cosmologists don't know the difference between forces and geometry, space-time curvature, what they can do. Here's another one that I like. They tell us that from this equation for a black hole, that there's an event horizon at r equals 2gm over c squared. When you put that in, you get the r squared over 0. That's a division by 0. They tell us that's infinity. Well, we all learnt in lower high school that you cannot divide by 0 because it's undefined. Then they go through this singularity down to another one, where r is actually 0. Again, they get a division by 0. And they tell us that this is the real singularity. The other one's a fake one. Because they can remove it with their imaginations. Here's what they tell us about this singularity. This is from Dodson and Poston, tensor geometry. Once a body of matter of any mass m lies inside its Schwarzschild radius 2m, it undergoes gravitational collapse. Gravitational collapse, we'll put a tag on that, we come back to it. And the singularity becomes physical, not a limiting fiction. So they divide by 0, it's not a limiting fiction, so we're not talking about limits in calculus, we're talking about divisions by 0. And they say it's a real thing, it's physical. Of course, what is the physical thing? 0 volume, infinite density, infinite gravity. Here's Caroline Ostley. This is a large book on modern astrophysics. A non-rotating black hole has a particularly simple structure. At the center is the singularity, a point of 0 volume and infinite density where all of the black hole's mass is located. Space-time is infinitely curved at the singularity. The black hole singularity is a real physical entity. It is not a mathematical artifact. So they're telling you, yes, you can have 0 volume, finite mass, infinite density, infinite gravity, and you can divide by naught twice. Meisner, Thorne and Wheeler have written a book. It's as big as, well, it used to be as big as a Sydney telephone book. It's half the size of a Sydney telephone book now. Sydney's grown, not because their book has. One says that r equals 0 is a physical singularity of space-time. So there can be no ambiguity as to what these experts assert. It goes on with Hawking. These are the singularities again. There must be a singularity of infinite density and space-time curvature within the black hole. Yeah. Now we come to Roger Penrose, a friend of Hawking. As R decreases, the space-time curvature mounts in proportion to R to the -3, becoming theoretically infinite at R equals naught. But as I said, no finite mass has zero volume, infinite density, and infinite gravity anywhere. This is a fairy story. Here's another paradox. This one has a little bit of mathematics in it, but the top here is Einstein's field equations. The two terms on the left-hand side constitute his tensor for space-time curvature. Lambda is the cosmological constant that they implement, and the right-hand side is his energy momentum tensor to describe the material sources of his gravitational field. And they say, well, when R sub UV equals 0, we get a Schwarzschild universe. Now note that to get R sub UV equals 0, you set T sub UV equal to 0. The other parts disappear because of a mathematical relation, which I won't go into. So it doesn't look like it, but it does because of a tensorial relation. So you get R UV equals naught. This is the so-called Schwarzschild universe from which they generate a black hole. Now, the next one, RU sub UV equals lambda G, little g U sub UV. Now, notice here that this leads to de Sitter's empty universe. Now, why is it empty? Well, precisely because T sub UV equals 0. So that means there's no material sources in this universe by this mathematical constraint. Go back to the previous one. The same constraint is there, T sub UV equals 0. And yet they tell us that there is a mass in that universe. So now we have, by the very same mathematical constraint, matter is both present and absent in a universe. Well, that's a logical contradiction. You cannot have matter present and absent by the very same mathematical constraint. As I said, this is all inside some Big Bang universe. We'll quote Hawking again. This is from his book, A Brief History of Time. I saw William Shatner on a video recently. He says, I tried to read that book. He said, I couldn't go past a few pages or some words to that effect. And then he said, I can't. He says, to me, science and science fiction, after trying to read this stuff, science and science fiction are one and the same. He's right, in current terms. Okay, so at the Big Bang itself, the universe is thought to have had zero size and to be infinitely hot. Let's think about that. Zero size and infinitely hot. First, what is temperature? Well, according to chemists such as Linus Pauling, who wasn't bad at chemistry, and lots of other physicists and such, the temperature of some substance is what? It's a measure of the kinetic energy of the particles. Now, these particles are moving around in space. They also occupy space because they have masses. And the more energy they have, the faster they move, the temperature goes up. So how fast must particles be moving to have an infinite temperature? Second, if you've got zero volume, where are the particles? Where are they going to live? You have no volume, so they can't be there, and they've got no place to run around in. This is one of my favourites. I've quoted it a number of times, but it's so wonderful that I have to do it again. This is from Meissner, Thorne and Wheeler's telephone book. One crucial assumption underlies the standard hot Big Bang model, that the universe began in a state of rapid expansion from a very nearly homogeneous isotropic condition of infinite, then in brackets here, or near infinite, density and pressure. So now they're getting pressure as well as temperature and density of being infinite. Now I ask you something. How close did Meissner, Thorne and Wheeler get to infinite to know when they were near it? This is a nonsensical statement. People read this thing and they think, well, these guys are geniuses. How did they do it? So I've just a little note here, infinitely hot nothingness. Does that make sense? Infinite or near infinite density and pressure. Yeah. Where was the pressured surface? You know, if you've got pressure, what's the definition of pressure? Force over area. Well, we've got zero volume. Where's the surface? But no, these geniuses tell us that they have infinite or near infinite pressure in zero volume. And of course, this is a lead up to what I'll have some words to say on shortly. There was no condensed matter, so what emitted the black body spectrum? This is their cosmic microwave background that was generated by their Big Bang universe within 400 years, before it was at the tender age of 400,000 years. It's got this radiation. Where did it come from? So that's a lead up to what I'm going to say shortly, after I discuss here Kirchhoff's law of thermal emission. Now this is a very important issue. It's central to physics and astronomy, and it's actually false, but they believe it to be true. If you take a box, and it doesn't matter what you make of it, as long as it's opaque, right? According to Kirchhoff, who was a German scientist in the mid-19th century, he said if you take a box, you heat it up, and you keep the temperature stable, there's a radiation field inside. Well, we know that things radiate. You get an infrared camera and you look at things and they're radiating. So this box radiates. And inside, because it's hollow, there'll be a radiation field. He was of the view that if you take any arbitrary opaque material and make a box of it, it doesn't matter what shape or size it is or what its material is, right, as long as it's large enough so that diffraction is unimportant. Well, diffraction is on a small scale anyhow. He says here, arbitrary opaque cavities at thermal equilibrium, and I put magically because it's magic, magically contain the very same radiation field as one made of carbon at the same temperature. So miraculously, if you made one out of granite, or if you made one out of highly polished silver, or any other opaque material, doesn't matter. It's just as though they were all made of carbon. Do you think that makes sense? How does all of these materials become the same as carbon? Well, they don't. And he says that the nature and form of the walls are irrelevant. Okay, so that means it doesn't matter its size or shape. But the truth is, the materials always influence the emission field. Here is an example of a black body spectrum. Now, I should say that these boxes that Kirchhoff was talking about, he called it black body radiation because he used to line boxes when he did some experiments with soot or lamp black. And that's black. So this is carbon. And carbon has this property. So it's called black body or normal radiation. And when you look at the spectrum from such a material, it has this kind of profile. It goes up in a hump and it comes down. And I've given a few here. And you see that with increasing temperature, the peak of the temperature, or the peak occurs at smaller and smaller wavelengths. So you heat it up, the wavelength will shift in this graph towards the left for the peak temperature. And you see that if you have a graph like this from a spectrum of some material, you'll say, well, I can look at this spectrum and I can find its peak and then I can tell you what the temperature is of the emitter. Well, that's okay, provided it's a carbon box. But what if it's not a carbon box or it's not a carbon material? You might get a profile that has this kind of distribution, but does it tell you the temperature of the emitter? And the answer is no. Not unless it is a black body, such as carbon. Well, most materials are not. Now, what is a black body? I should tell you that. Theoretically, it's ideal. It means that all the radiation that falls on it is absorbed immediately, and all the radiation then is converted and re-emitted, so that at thermal equilibrium, there is no change of temperature because the radiation that comes in gets absorbed and it gets re-radiated. So there's no change of temperature, but there's an absorption and emission from the surface of the material. That is a black body. Now, it's ideal, but it's very closely approximated by soot. Now, there's a thing in the theory, the other boundary is an ideal and re-emitted. An ideal reflector is one that absorbs nothing. Everything that falls onto the reflector is reflected. So it absorbs nothing. So it cannot increase its temperature by radiation because it can't absorb any radiation to increase its temperature. It reflects it all. So if you have now an ideal reflector and you have a radiation coming off it, it's reflected radiation, you look at it, you get a Planckian spectrum, and you say, oh, well, I can get a temperature, and you take the temperature. Is that the temperature of the reflector? Well, the answer is no, because this radiation didn't come from the reflector. It came from the surroundings, was reflected off the reflector, and does not report the temperature of the reflector. The reflector cannot emit because, by definition, it has no emission capability. It has absorption of 0 because it's a perfect reflector. What's a perfect reflector? Well, do they exist? No, but they are closely approximated by things like highly polished silver. It has a reflectivity of 0.9991 or something like that. So it reflects pretty well everything that falls on it. This has implications for spectra of all types. Cosmologists do away with the enclosure, they do away with thermal equilibrium, and they assume that Kirchhoff's law is still true and that they can universally apply Planck's equation. Now, Planck developed an equation to describe these curves, and so they apply Planck's equation to any spectra that they get, and they think they can get temperatures. So we have now some spectra from some stars. We've got Spica, the Sun, and Antares. And you see here that the temperatures reported by these spectra are 23,000 Kelvin for Spica. The photosphere of the Sun is at 5,800 Kelvin. And Antares is at 3,400 Kelvin. But are these stars black bodies? Well, they're not. They're not carbon. And they don't satisfy the conditions that strictly require the application of Kirchhoff's law, and hence Planck's equation. So the temperatures that are received from these are what? Too low. The reason why they're too low is because a black body emits the maximum amount of energy. These are not black bodies, so they will emit, in a profile, they will emit energy levels that are lower than what a black body would have done. So this temperature that you assign to it is actually lower than the temperature that it should be. So these are apparent temperatures. This is important as well for the CMB because it's allegedly a black body spectrum at approximately 2.725 Kelvin. Here's Planck's equation for spectral density. Nu is the frequency, and C is the speed of light, 300 million meters per second, not 0. And K is Boltzmann constant, H is Planck's constant. This is important because Planck introduced the quantum of action in this expression, and that spawned quantum mechanics. So if Planck's equation is not universal, and quantum mechanics and astronomy as such assume it is, which it isn't, then they've got a lot of problems. So strictly speaking, this applies to a black body, an opaque solid at thermal equilibrium within an enclosure. So if we get rid of the enclosure and such, we can approximate some materials, such as plates and things, by this equation. But it's not universal, contrary to what physics and astronomy believes. So we need to know, how does a thermal spectrum produced? Well, the fine details of it are not known. But what we know is that it's opaque solids produce, or opaque solids produce it. Also, liquids can produce a thermal spectrum. And this is due to their lattice structure. So there's a vibration of the atoms or molecules in the lattice structure that produces this. So Professor Pierre-Marie Robitaille published in 2003 in the Transactions of Plasma Science in the IEEE an article about this, and here's a quote from it. Interestingly, Planck never sought to bring full physical meaning to his own law by linking it to a specific physical process undertaken by a specific physical species in a specific physical setting. In this sense, Planckian thermal emission remains unique in physics to this day. Scientists have yet to link the production of a thermal photon in blackbody radiation to a direct physical cause. The situation can be corrected if true blackbody emission is viewed as consequence of the vibration of atomic nuclei within the confines of a lattice structure. Well, here is a profile of the Balmer series of the hydrogen atom, and you see that it's in line emission, just lines. It's not this Planckian distribution. This is typical of gases. So a thermal spectrum requires a lattice, and only condensed matter has a lattice. Liquids and solids are condensed matter, but gases are not condensed matter. But the hypothetical Big Bang primordial gaseous exotica, well, how can they emit a thermal spectrum? This is their cosmic microwave background made up of electrons, protons, neutrons, quark-gluon plasmas, whatever that is. Here's an interesting thing about black holes and thermal emission. Now, this Hawking radiation, it's supposed to be a black body radiation from black holes, one way or another. And but But black holes are not condensed matter. They're not solids and liquids. They've got no volume. The singularity has no volume. And they have no lattice structure since the singularity has no volume. So they don't have any material structure at all. And yet, this phantasmagorical black hole, it has no means to produce a black body spectrum, but according to Hawking, it does. So black holes violate the physics of thermal emission. Well, you need something to emit. You can't have a mass that doesn't have a volume. It doesn't even have a surface, and yet it emits. Wonderful. Gravitational collapse. This is very interesting. Recently, Professor Robert again has addressed it from the point of view of thermodynamics. And the truth of the matter is we can analyze black holes now without any equations. We just go to some laws of thermodynamics because they violate the zeroth, first and second laws of thermodynamics by this process of gravitational collapse. And in so doing, they produce perpetual motion machines of the first and second kind. Well, thermodynamics forbids perpetual motion machines. And a free gas can't do work on itself and make itself collapse, because if you take a gas and you put it in a container, it spreads out and fills the container. And if you want to compress it, you have to apply a force, just like you do with a bicycle pump. You have to apply a force and the temperature goes up. You can feel that when you use the bicycle pump, right? But you've got to now, you take this container of gas and you put it inside another container and open it up. The gas squirts out, fills the container. And then now if we do away with the walls completely, what happens to the gas? Will it collapse on itself? Well, it'll continue to spread out. That's what gases do. So they can't collapse on themselves. That would be doing work on yourself, and that's forbidden by the laws of thermodynamics. But black holes are formed by gravitational collapse of free gases. So this is a very important point. In thermodynamics, there are two basic quantities. There's an intensive property and an extensive property. And temperature is an intensive property, not an extensive property. Here is a way to see the difference. Take a brick, and we heat the brick up, and we get it to a certain temperature, and we keep it there, right? Now I cut the brick in half. The two pieces now have different masses, but the temperature hasn't changed, has it? The temperature stays the same if I cut them again, but the masses reduce. The temperature stays the same. The temperature is called an intensive property. Right? The mass is an extensive property because it changes with this process. Right? So you cannot define an intensive property in terms of an extensive property. But that's what cosmologists do with their black hole thermodynamics. They redefine temperature unwittingly using an extensive property, mass, to define an intensive property, temperature, in direct violation of the laws of thermodynamics. So the Hawking-Bekenstein thermodynamics of black holes is nonsense because thermodynamics forbids it. Now, Big Bang creationism, I think it's the best of all because the Creator created itself. But I'll come back to say a few more things about that. But Big Bang creationism requires validity of Kirchhoff's law of thermal emission and universality of Planck's equation. Now, why do we mean by universality of Planck's equation? Because Kirchhoff made all the boxes black ones. Planck's equation applies to all boxes. So it doesn't matter what the box is made of, they think the equation can apply, but it doesn't. So Kirchhoff's law is false, and Planck's equation is not universal. Now, I've given here an example of a thing that produces or proves that Kirchhoff's law is false, and it's MRI. The clinical existence of MRI, which is magnetic resonance imaging, proves that Kirchhoff's law is false because if Kirchhoff's law is true, then all the radiation in the walls of a cavity can go into the radiation field. But if that is true, then MRI couldn't exist because MRI is facilitated in the same process as NMR. And that means that there's spin lattice relaxation. Lattice is what? The structure of the material. The spin relates to the protons in the atoms of the structure of the material. If all the radiation in the walls was permitted to go into the radiation field, you would have no way of having spin relaxation and they produce MRI images. You wouldn't have a resonant device because you could not build up a standing wave inside a resonant cavity because all the radiation would be absorbed and then re-emitted. But we have resonant devices everywhere in microwave technologies. So all cavities are not black. So the clinical existence of MRI is proven that it's not. But the simplest one is not MRI. The simplest one is an experiment done recently by Professor Robothay, and it's been online for 3 days only. Now, I couldn't put it in my slides because I had to prepare it beforehand. But a simple experiment that you can do in your kitchen with about $1,000 worth of equipment at most, not $1 billion satellite, right, proves to you that Kirchhoff's law is false. So if you go to Professor Robothay's website on YouTube, you just do a search on Sky Scholar, 2 words, Sky Scholar, and look for his lecture on his experiment. It's called Is Kirchhoff's Law True? The Experiment. Now, since Kirchhoff's law is false, the whole of cosmology is dead. Why? Because without it, they have no cosmic microwave background and no Big Bang. So now it's proven false by a very simple experiment. We don't have to use a single tensor equation and get confused about it. So that would be something that I'd recommend to you all to go and have a look at, because it affects not just astronomy, but a lot of physics, condensed matter physics, quantum mechanics. Everything's affected by this because Planck's equation is not universal. Now I want to look at some conservation laws regarding general relativity. Now, general relativity cannot localize its gravitational energy. That means you cannot have gravitational waves with this theory. Here is how Einstein tries to get conservation of energy and momentum. If you take a closed system, we know from many, many experiments that the total energy and momentum of the closed system is conserved. This is fundamental in physics. Now, Einstein knew that, so he had to find a way to make his theory comply with this experimental finding. And so, what is energy? What is the energy and momentum to Einstein? It's everything except his gravitational field. That means electromagnetic radiation, mass, etc. All of this is matter, and it contributes to the curvature of space-time, right? So he needs now some way and means of accounting for the energy of his gravitational field, because in a closed system you'll have the material sources and you'll have the gravitational field. We want to take the total energy and momentum of that closed system and then conserve it. So he invents a thing. Well, he's got his big T. I've put them down the bottom there. The total energy and momentum is equal to little t with a superscript and subscript, and the big T is his energy and momentum tensor for the matter. What's the matter? Everything except his gravitational field. So he invents a thing called his pseudotensor, the little t, to represent the energy and momentum of his gravitational field, and he adds them together to get the total energy. But this is not a tensor equation, so he can't deal with it as a tensor. So what does he do? Formally in mathematics, if you take a divergence of this expression and get 0, you have a conservation law. So he can't take a tensor divergence, so he takes an ordinary divergence, and then he pronounces this. Thus, it results from our field equations of gravitation that the laws of conservation of momentum and energy are satisfied. Here, instead of the energy components of T, it's a little displaced, but sigma mu, the gravitational field, we have to introduce the totality of the energy components of matter and gravitational field. Okay, so now he says we got a divergence of 0. First, it's not tensorial, so that violates his fundamental premise that they must all be tensorial. The second thing is this. This is complicated expressions, but that doesn't, you don't need to know it. It's the outcome. When we look at the definition of Einstein's pseudotensor, that's that complicated expression at the top. Because it's like a tensor, he says these quantities, T, alpha, sigma, we call the energy components of the gravitational field. Well, since it's like a tensor, it's a pseudotensor, we can treat it like a tensor. And so we do this thing called contraction in the second line. And it produces an invariant. Now, the invariant has the property of being a first-order intrinsic differential invariant. This is what which means that it's made up of the components of the metric tensor and their first derivatives and nothing else, which is the last expression. The G's are this metric tensor. But in 1900, the pure mathematicians who invented this mathematical apparatus proved that you cannot construct a first-order intrinsic differential invariant. They don't exist. And yet, Einstein and his followers managed to calculate the energy of a gravitational wave to model their alleged physical phenomena with an entity, a mathematical concoction of symbols, right, that doesn't even have validity in mathematics. This is really miraculous. So there's only one way to really write Einstein's field equations, so that they can be tensorial and satisfy a conservation law as a formal mathematical expression. And you see the total energy is the top equation. This is how you write them. And then the second equation is a tensor divergence, and it's 0. So we say, wait, we've got now a formal conservation law. But notice something. The top equation is the total energy and momentum of a closed system. It's always 0. There's no other way you can write Einstein's equations to satisfy this. But where in experiments do we find that the energy and momentum of a closed system is always naught? This is nonsense. But this is the only way you can do it. So the theory is fundamentally, logically inconsistent and mathematically drivel. Now I come to the whole object of the thing, what LIGO did. We see that you cannot have black holes in Big Bang universes. The whole thing is inconsistent. So where do they get their gravitational waves from? They get it from a wave equation. But the wave equation does not come from black hole equations. They're talking about black holes generating their waves. It doesn't come from Big Bang equations. Their black holes are inside a Big Bang universe. It doesn't come from Einstein's nonlinear field equations. It comes from a linearized form of Einstein's field equations, because you can't solve the nonlinear ones. So they linearize them like Einstein did and get a wave equation. And then they say, this wave equation tells us that the waves travel at the speed of light. No, they don't. Here's LIGO's gravitational waves at the speed of light. Bearing in mind, of course, that they have two different speeds of light for their black hole escape, 0 and 300 million meters per second. In 1916, this is in the LIGO discovery paper, in 1916, the year after the final formulation of the field equations of general relativity, Albert Einstein predicted the existence of gravitational waves. He found that the linearized weak field equations had wave solutions, transverse waves of spatial strain that travel at the speed of light, generated by time variations of the mass quadrupole moment of the source. There's a lot of jargon there, but it just tells you that they're supposed to be traveling at the speed of light. Let's look at these linear equations. There they are, right? The new, they just take the values 1, minus 1, minus 1, etc. And the other ones are little tiny changes in the flat space. We don't have to worry too much about it. Here's the derivation. They truncate what's called the Ricci tensor to be able to do their mathematical mumbo-jumbo. Then they set the second part to naught. And then you end up with a wave equation. And it says, well, this one travels at the speed of light. You know what? This whole thing is coordinate dependent. You can change the coordinates and you can have any speed you like. So their claim that they travel at the speed of light, Einstein's included, is utter nonsense. It's a coordinate dependent speed, so they don't have such a speed. Now I come to LIGO's devious methods. Let's assume multiple black holes inside a Big Bang universe like they do. Let's assume gravitational waves propagating at the speed of light like they do. Now we take meaningless equations to manufacture trajectories of multiple black hole interactions, and we generate from those equations, using our computers, 250,000 templates. Template is their fancy name for a line of best fit. Right? 250,000. And associated gravitational waves. Of course, this is the multiple black holes inside a Big Bang universe that they have no real equations for anyway. They just made it up. Then they generate these 250,000 and put them in a database. Then LIGO says, I've got a generic noise, fellas. So the scientists at LIGO say, that's wonderful. What we'll do is we'll put it into our computer and we'll try to find from our own equations that we made up a line of best fit to the noise that we just got. Then they find one. It's a line of best fit. It doesn't have to be exact. You know, it could be right off. It doesn't matter as long as it's close. It's the closest of your 250,000. Then they say, well, that model is for two black holes circling on another thing at this speed and produces this. So that's the physical cause of the wave, of the noise in our device from an equation that we made up from our own nonsensical equations. So we look at the database. Here it is. I couldn't do 250,000 of them, so I don't know how many are there. Someone might like to count them. Anyhow, LIGO says that there's still this little one at the bottom. That's their line of best fit from their 250,000 database, from their own manufactured lines of best fit. Here's their devious graphics. Notice at the top, they've got two black holes. It's a binary system. They're rotating around each other. Then they coalesce. They call it a chirp. It makes a noise, you know, like a bird. Yeah, I'll tell you about David Wrightsey because I saw him in Queensland. He was talking about chirps. Anyhow, This thing here is a chirp. This waveform, it makes a noise. They generate the noise. Maybe they got a contract with Marshall for their speakers, I don't know. Anyhow, again, it's that little tiny dot there, that noise that they got there. They say, well, you know, that matches the line of best fit from our 250,000 database is this one. So that's the one we'll pick. And then they tell the world we discovered them. Well, with that kind of computing power and that kind of so many degrees of freedom and the ability to generate whatever you like as a database, you can find a line of best fit in LIGO for Whistler's mother. There she is. And it's a different one, you see. LIGO's at the bottom, Whistler's mother's up the top. So I want to tell you a little story before I come to my final slide. In December last year, David Wrightsey went to the University of Queensland at a teachers' conference, high school teachers' conference. And I went up there because I'm in Tasmania, right? Don mentioned Tasmania. I was pleased to hear that. Anyhow, so I go up to see him, his lecture. But before his lecture, I went to some of the teachers' workshops. I just wanted to see what's going on here. And in the state of Queensland, it is now mandatory, directed by the Department of Education, that children as young as 12 must be taught Big Bang creationism, black holes, and the whole paraphernalia. Can you believe it? Stephen Hawking might be very happy about that because he's written a series of books for 12-year-olds. Mr. George goes gallivanting with black holes and Big Bangs, depending on which book you pick. It's written for 12-year-olds. There's about 3 of them, at least, that I know of. But that's what the state of play is in the state of Queensland. I wouldn't be surprised if it's the same here in the US now. Anyway, at his lecture, I listened to his carry on, and I sat up right up near the front so I could see the whites of his eyes, you know. And he, of course, he doesn't know who I am. I know who he is because I've seen him on television. We've done it, he says, like this. We've done it, we found him. We've discovered gravitational waves. Well, you know, this is how science is done now. Scientists are now got a new method, mass media-induced mass hysteria. This is how they do science. Did you see the guys with the Higgs boson when they announced that? They were jumping up and down, hugging one another on international television as though they just scored a winning goal at the World Cup final. This is the new way to do science. Well, it might be their way, but that's not the real science way. Anyhow, so I discovered that Wrightsey was just doing the same thing that other cosmologists do, gallivant around the world and tell people like Brian Cox, Larry Krauss, Richard Dawkins, Neil deGrasse Tyson. They travel around the world lampooning everybody else, anybody who disagrees with their creationism. And they tell everybody that your creationism can't be right because ours is the one and only and yours is a false prophet. Another little story before I go to the last slide, if you've got time. Yes, a little bit of time. The cosmologists are now spending, or they're led by Hawking, by the way, they're spending $100 million of Milner's thoughtless money. Now, Milner is some Russian billionaire who likes to throw money at cosmologists and string theorists. No one who does real science, but these kind of guys. And he gives them $3 million a piece. You know? And if you happen to be Stephen Hawking and you didn't get one, you get a special dispensation and you get another $3 million. And to top it all off, how does Milner set up his grants? Everybody who won it this year sits on the committee to decide who wins it next year. Well, you know what the outcome will be, won't you? More string theorists and more cosmologists, of course. So anyhow, they travel around the world doing these sorts of things. Now, Wrightsey's doing the same thing. He's just going out there. He's the solo artist for the LTC. What's the LTC? That's the LIGO Tabernacle Choir. So he goes around, he sings the praises of LIGO, and he wants everybody to spend billions of dollars to build new LIGOs for them and lasers so they're in space and they can do more gravitational waves in black holes. Of course, none of it exists. And during that talk, he made a remark to all the teachers in the audience. They're listening to him, and he says, you know, Newton's theory of gravity appeared in about 1643. And I looked around the room, and it seemed that I was the only one who had a problem with that statement. The reason is this. Newton is heralded as being the greatest genius of all, right? But I doubt very much that even he could have written down a theory of gravity when he was aged 1. That doesn't deter Mr. Wrightsy and the other cosmologists from making these calculations and with nonsensical forms, etc. So that's a lead up. Oh, I have another little story. This is really funny. There's a web blog, a news blog called The Conversation. It's based in Australia. And some Australian scientists put up an article there about these black hole gravitational wave stuff with LIGO. And it was so nonsensical, I couldn't resist, so I went in there and I put in some scientific remarks. And Wal will know this because he did it too. He told me about it. So I went there and made some comments as well, so he knows the men I'm talking about. Well, the leader of this group is Professor Matthew Bayliss of Swinburne University of Technology in Australia. And he's one of the guys that are spending $100 million of Milner's money. I forgot to tell you what they're doing it for. They're trying to contact aliens. I'm serious. They're trying to contact aliens with this $100 million, and Bayliss, according to the article, is the leader of the Australian contingent. And they want to use radio telescopes all around the world, including the Parkes radio telescope. So he didn't like my response. He didn't like Wal's either, but he didn't like mine in particular, so he came and made some statements. He says, I'm confident in the general theory of relativity because I've found quasars and observed quasars. That's it. Well, you know what? I'm sure that a fishmonger would have confidence in the theory of relativity because he found and observed fish. So, I have to say this. LIGO is a fraud. It's a scientific fraud. It has absolutely nothing to do with science. It's all to do with who knows what. Money-making, mesmerization, mystery, mysticism, but it's not science. And as I said, it's science by using mass meter-induced mass hysteria. So I'll conclude there, and you can have probably a well-earned break. Thank you very much for listening.